Now in this video we're going to look at the difference between a continuous graph and a discrete graph. All the ones that we've talked about so far have been continuous graphs, even the one in the word problem example. And the reason that was a continuous graph, and the main thing with continuous graphs is that they can be drawn without picking up your pencil at all. They can be drawn in one continuous curve or one continuous loop. And one thing we think about with continuous graphs is that with continuous graphs, fractions and decimals work in that situation. For discrete graphs, which are composed of distinct isolated points, we would graph those with dots. For those, for the discrete graph, fractions or decimals don't make sense. They don't make sense in that situation. So that's the main thing that differentiates a continuous graph from a discrete graph, is whether fractions make sense or not. So on the next page we've got a couple of examples we're going to talk about, and we're going to try to explain whether they're continuous or discrete. The amount of water W in a wading pool in gallons depends upon the amount of time T in minutes the wading pool has been filling. And it's related by the function W equals 3 times T. So, in this example, we have to ask ourselves, in time, can we use fractions or decimals? For example, if we were using minutes for our time unit, does it make sense that we could be filling that for half of a minute or a quarter of a minute? If so, then it would be a continuous graph. And since it does make sense, we could fill it for 3.5 minutes or 4.25 minutes or something like that. This graph is continuous. And the reason it is continuous is time can be measured in fractions of a unit. So that's why that would be a continuous graph. Now, in example B, the cost C of baseball tickets in dollars depends on the number of tickets bought. Now, in this case, you're not going to buy half of a ticket to a game. You're going to buy a full ticket, 1, 2, 3, and so on. So this graph, if we just took a quick look, if you bought 1 ticket, you'd charge $16, 2 tickets, $32, and so on. So it's going to be graphed by distinct points. Fractions don't make sense. So in this case, this is a discrete graph. And the number of tickets will not be measured in fractions or decimals. They will be measured in whole numbers. So that's what makes that a discrete graph. All right, so that's the end. That's a brief introduction into graphing functions using a table of values and what makes a graph a discrete graph or a continuous graph. Tomorrow we will start discussing domain and range.